So now I want to look at how we can use simultaneous, how we can use matrix method to solve simultaneous equations. Alright? Here I have a pair of simultaneous equations here. A pair of simultaneous equations here. 3x plus 2y equal to 1. And 5x plus 4y equal to 5. So we did this earlier. Remember we did this earlier using the elimination method and so on. So I want to look at the matrix method. Good. Now, we have a solution here. A formula here. xy is equal to a inverse b. No. Alright, so we set it up like this. So a, xy. I just want to show you where this formula comes from. A, xy equal to b. What is a? What is b? A represents the coefficients here. Alright? A represents what we call the coefficients of the unknowns. So look at how we get a. Just the numbers over here. 3, 2. What other numbers we have over here? 5, 4. Alright? So a represents the coefficients of the unknowns. Alright? What we call unknowns, what we're trying to find, the x and the y. We don't know the values of x and y, right? That's what we're trying to find. So we call them unknowns. So the coefficients 3, 2, 5, 4. Alright? So the matrix equation that would represent this pair of simultaneous equation would be that. 1, 5, right? One, 5. So you would notice that if you should expand these brackets here, remember how you expand matrices? Row times column, right? So 3, 2 times xy, if I should expand 3, 2 by xy, remember it's first number times first number, second number times second number, so 3, 2 by xy will be 3 times x plus 2 times y, which is what we have here, equal to 1. And then representing, expanding the 5, 4 to the xy, so it's 5 times the x plus 4 times the y, and that would give us 5. Alright, so this is what we call the matrix equation of the original simultaneous equation. So what we call a, so we call this a 3, 2, 5, 4, the coefficients. Alright, up here. And then xy, and what we call b the constants over here. That's what we call b. Alright, so let me just write it again. So we have a representing 2, 5, 4. Alright, that's what a always represent. And b represents the constants on the other side, 1, 5 in this case. Now, you will remember when we were looking at the inverse and the you will remember when we were looking at the inverse and the identity and the relationship between that. Remember that if you should multiply a matrix by its inverse, what would happen? You get I. Alright, and that's what you want. And you know what I is? I is like the equivalent to 1. Good? In matrix theory. So the thing is, remember you want to find xy. So you need to get rid of this a there. And because you want to get rid of this a, you multiply this side by a inverse. Because a inverse times a is I. Just as though any number times its inverse is 1. If, as I said, if you multiply 7 times its inverse or its reciprocal, you get 1, right? So it's just exact same idea. You want to get rid of this a, so you multiply this side by a inverse. And we all know from our algebra, if you multiply the left hand side of an equation by a term, then you also need to do the same thing to the right hand side. So what will happen now is that this gives you 1, or 1xy. So you end up with xy equal to A inverse times B. And that is where this comes from, right? Good, so that's the reason behind this. Alright, let's solve a problem now. Alright, so let's solve a problem. Let's remind ourselves of what A is. What is A? A is just the coefficients over here, right? So A is all these numbers, 3, 2, 5, 4. Let's just remind ourselves what A is. Because you need to have A to get A inverse, right? Okay, so xy equal A inverse times B. Alright, let's do this now. So A inverse, now, remember the formula for inverse of a matrix? 1 over determinant times the adjoint. So let's deal with A inverse. Let's deal with A inverse. The inverse of any matrix is 1 over determinant times adjoint. Here's A. Let me put down the determinant of A. What's the determinant of A? Cross multiply 4 times 3, that's 12. Take away 5 times 2, that's 10. So the determinant of A is 12 minus 10, 2. Alright, so the inverse of A, remember, is 1 over the determinant of A, so it's 1 over 2, times the adjoint of A. And what's the adjoint of A? You can just swap these, so you get 4, 3. And then these change signs, so it's minus 2, minus 5. So what you're looking at there is of A. And then I would times it by B. And B would be the constants over here, which is 1, 5. And then we do our solution here now. So we have half. Let's keep the half outside for now. Let's multiply. So row by column. So 4 times 1, 4. Plus minus 2 times 5. That's minus 10. So it's 4 minus 10. We do the next row. Negative 5 times 1. That's negative 5. Plus 3 times 5. That's 15. So you end up with now half. And then what's 4 minus 10? Minus 6. Negative 5 plus 10. Negative 5 plus 15. That's positive 10. So continuing. Half of minus 6. That's minus 3. And half of 10. That's 5. So that's our solution. X equal to negative 3. That's x is the top value. And y equal to positive 5. Alright, and you can always test your solutions in the equation just to make sure it makes sense of it. We are saying that x is minus 3. So 3 times minus 3, that's minus 9, right? 3 times minus 3, that's minus 9. And what's y is 5? 2 times 5, that's 10. So negative 9 plus 10, that's 1. So we are confident that it works in this. Let's test if it works in the other one. If x is what? Minus 3. 5 times minus 3, that's minus 15. We're saying y is 5. So 4 times 5, that's 20. So negative 15 plus 20 give us positive 5. So we are confident it's correct. Let's try another one.